Today, you will learn all important functions in Python math module. So let's import the math module. I will import math module and give it alias m because I will show you a lot of functions and I don't want always to write math. First set of very important functions are not actually functions. They are constants in math that are used very often. For example, one very famous constant is pi. Another very famous constant is Euler's number, which is e. Constant pi has value 3.14, while constant e has value 2.72. Also, I want to show you how to represent infinity in Python. You need to write inf, which is short for infinity, and this is the greatest number that Python can represent. But when I print this, it will show inf, but Python will treat it as the biggest number. Now when I run this code, as you can see, Python printed me the values. 3.14 is pi, 2.72 is Euler's number, and inf is the infinity. Another important set of functions are rounding functions. For example, if I have a number minus 2.346, if I want to round up this number, meaning even though it has decimals and this shouldn't be minus 3, I still want to round it to 3, I would write m.ceil function and pass x. But if I want to round this to a lower number, for example, in this case, minus 2, but even though if I write here minus 2.7, this m.floor function would still round this number to minus 2. This always rounds the number to the smaller. But if I want to remove all the decimals, I would write m.trunc and then here pass x. Also, I want to show you how to write an absolute value of this x, which is the positive value, 2.346. You would write m.fabs, floating absolute, that is the shortcut, and pass x. Now when I run this, as you can see, ceil number rounds it to the first bigger, while floor rounds it to a first greater. And trunc simply removes all the numbers. I mean all the decimals. Now I will show you a regular set of functions like power function, logarithmic function, trigonometric function, square root function, etc. If I want to represent power, I would write print.m.pow, which is short for power. First number is the base, let's say 2, and the next number is the exponent, 3. But you could write this like this. This is the same, and usually you should use this. Also, if you want a square root, in that case, you would write m.sqrt, which is square root. If I pass 5, this will calculate me the square root of 5. But as you saw, there is I square root. This is short for integer square root, which will round this 5, the square root of 5, to an integer number, 5. So this should print 2. If I run this, as you can see, 2 to the power of 3 is 8, and 8. They printed the same. Square root of 5 is 2.36, but the I square root rounded this, converted this number into an integer, which is 2. If you want logarithmic function, you need to write m.log. These three are the base because they're commonly used. So this is log with base 10, log with base 2, and I don't know what this is. I usually use only these two and this one here. This log function has the base, neutral base, which is Euler's number e, if you don't pass a base. But if you pass it, it will be the one that you passed. So for example, 3.3, this log should print 1. But if I write m.log 3, this number should be slightly greater than 1. Also, there are some trigonometric functions. For example, m dot sine of m dot pi half, which should be 1. There's also cosine, also tan, also hyperbolic tangent, etc. There's also arc cosine. For example, arc cosine of 1 should be 0. Now when I run this, as you can see, log of 3.3 is 1, but neutral log of 3 is slightly greater than 1. Sine of pi half is 1, and arc cosine of 1 is actually 0. Another useful functions that Python has, and not many other programming languages have, are greatest common divisor, which is m.gsd, and here you can pass as many numbers as you want. You don't have to pass 2 and 3, I mean only 2 numbers. As you can see, there's asterisk here, which indicates that you can pass as many as you want. For example, 4, 2, 5, etc. But let's put here 6 and leave this. Also, if it has greatest common divisor, it usually has least common multiple, LCM. Again, here you can pass as many numbers as you want. Let's pass 2, 3, and 5. And another useful function is factorial. Factorial is calculated like this. For example, if I have 3 factorial, which is represented in math as 3 exclamation mark, is calculated like 3 times 2 times 1. If I have 4 factorial, is calculated like 4 times 3 times 2 times 1. I think you see the pattern here. So I could here write m dot factorial of x. And now when I run this, oh, I made a mistake. Here should be factorial of 3. Greatest common divisor of 2, 4, and 6 is indeed 2, and least common multiple of 2, 3, and 5 is 30 because they are prime numbers and you should only multiply everyone. So 2 times 3 times 5 is 30. 3 factorial is, as I have shown you, 3 times 2 times 1, which is 6. Python has a lot of useful modules. If you want to find out more, subscribe to my channel. In future videos, I will cover more modules.